This is the Ryan Firebee, ready for launching from a mother aircraft. It is a high-speed, high-altitude, jet-powered aerial target plane designed for pilotless operation and recoverable by parachute. It simulates the performance and maneuverability of fighter aircraft. The Firebee's uses as a target include training in air-to-air gunnery and in the operation of anti-aircraft weapons. The Firebee was developed by Ryan Aeronautical Company under joint sponsorship of the Air Force, Army, and Navy. It operates in a speed range of 250 to 530 knots and at altitudes from sea level to 40,000 feet. It is designed to provide for 10 straight and level gunnery runs at 15,000 feet and is capable of either air or ground launching. Flight testing has taken place at Holloman Air Development Center under technical supervision of the Air Research and Development Command and Wright Air Development Center. The all-metal Firebee was designed for ease of assembly and maintenance. It has 5 major components. The mid-wing is a 45-degree swept-back type without incidence or dihedral. It employs a symmetrical airfoil section and is constructed of aluminum and magnesium alloy. The wing of the Firebee attaches to the fuselage by 4 bolts, and alignment of the wing is assured by the use of conical-type fittings. The empennage assembly is made up of 3 identical stabilizer and control surface sections which provide standardization and greater ease of manufacture and maintenance. The empennage assembly with its associated control system components is readily attached to the fuselage by 4 bolts, again through the medium of conical fittings. Construction is of magnesium alloy skins and aluminum alloy spars. The 2-stage parachute recovery system consists of a 5-foot diameter drag parachute and a 70-foot diameter main canopy. The parachute containers are attached by means of explosive bolt mechanisms. The next step is the attachment of the engine nacelle to the fuselage. The fuselage is the main structural assembly and contains the guidance and remote control system as well as the 4 fuel cells. An A-frame is used as an aid in completing the assembly. The forward protruding section or bullet of the nacelle contains the engine accessories, which include the starter generator, tachometer generator, engine-driven fuel pump, and throttle actuator. The A-frame allows the nacelle to be walked under the fuselage, where it is hoisted into position and attached. Assembly operations normally require 3 men. The power plant is a Fairchild J44 turbojet engine with a static sea level rating of 1,000 pounds thrust. The engine nacelle is attached to the fuselage by 4 bolts. The forward bolts act as hinge pins and allow the nacelle to be lowered for servicing of the aft portion of the engine. With the attachment of the nacelle to the fuselage, the assembly of the target is completed. Following assembly, the drone is returned to the hangar, where through the combined efforts of Air Force and Ryan personnel, all equipment is given final servicing and inspection. Drone is now installed on a roadable cart as required for a particular launching installation. The Firebee has a span of 11 feet 2 inches, length of 17 feet 6 inches, and is 6 feet 2 inches high. Empty weight is 1,146 pounds, and gross weight with 105 gallons of fuel is 1,768 pounds. Inside the hangar, activity on the target is speeded up. A definite shop schedule has been set by Air Force and Ryan supervisors following the establishment of a flight date. The intricate electronic equipment is given a thorough bench test prior to its final installation. Autopilot components also receive their final calibration. During all flight evaluation tests, targets are equipped with telemetering devices which require additional time for service and calibration. The remote control equipment is given a final shakedown and tests simulating in-flight conditions are performed. The testing of the Firebee in the shop is carried out through the medium of an umbilical cord which is attached to the target. All in-flight command functions can be duplicated by this direct means, which allows testing in the shop to be conducted with external electrical power. Following an overall shop test, which includes remote command, the target has been towed in its handling fixture to the Ryan pad at Holloman and is readied for the ground run-up of the engine. In this test, as in most of the other pre-flight checks, service personnel actually perform the testing. Ryan personnel act primarily in an advisory capacity. During the engine run-up, all electrical equipment is operated from the engine-driven generator. This provides one more step in the system of tests required before flight. The remote control system is given another check with the power plant in operation. Movements of the ailerons and elevator are checked against calibrations made in the shop. The target must pass each of these successive tests in order to be considered ready for flight. After completion of all tests, the Firebee is returned to the shop for fueling and for final weight and balance checks. Here it's being towed to the flight line for attachment to the launching plane. Everything is in readiness. Range facilities have been scheduled by the project office. A crew has been assigned for the flight testing. As the time for takeoff approaches, preparations are underway for loading. Meanwhile, key personnel have been dispatched to the remote control station and the telemetering receiving station in preparation for the flight. The B-26 launching aircraft is placed over a pit, and the target is wheeled into the pit for hoisting into the bomb bay. A check run on all target electrical equipment will be made just prior to the takeoff. When the drone is attached to the bomb shackle in the launching aircraft, sway braces will be adjusted and a final shakedown made. The flight test crew is given a final briefing just before takeoff. The crew of the launching aircraft, including the direct control check operator, is made up entirely of Air Force personnel. The flight pattern and tests to be performed are gone over in detail. The particular mission for this flight requires a photo chase plane to record the Firebee's performance. A T-33 has been provided, and the pilot and photographer prepare for takeoff. The B-26 aircraft takes off with its Firebee snugly secured in the launching position. The engine of the captive target will not be started until a few minutes before release. In the mobile radar station, the remote control panel is plugged in. From this point on, the operator will see the Firebee only on the plotting board. Radio contact has been established with the launching aircraft and the chase plane. An F-86 pilot provides a running commentary. The target engine has been started.
Transfer to internal power and prepare for release.
The final countdown begins.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You're up. Are you clear? Just holding straight and level. Wait a minute. Still descending just a little bit, leveling out and holding a straight course. The missile should stay at this altitude now for the remainder of the flight. Please notify us of any deviation. Oh, roger, will do.
The remote control station tracks the bird and commands the flight from the control box.
What is your airspeed now, please? Stand by. I'm latching on to him. I'll give you a good accurate airspeed in just a second. I got about 380 here, and my altimeter is 20,500. This was leveled out. I'm latching on to him right now. Oh, roger.
The other range facilities are now busy at work. The optical and radar tracking equipment is constantly following the target in flight. Command signals to the drone go out over the radar system. The commentary between the remote control station and the chase pilot in the F-86 goes on steadily.
I'm gaining on the missile now. You walked off and left me there for a while. The missile rolled out and rolled right into the left bank again. I have an indicated airspeed of 340 and just about holding my own with the missile, maybe gaining a little. Altitude is 20,200. The missile is in a gentle climb. Altitude approaching 20,500.
Watch closely now for the parachute recovery, which is commanded at the end of the flight test.
How's the recovery? Okay? Well, the recovery is pretty good. Your altitude now is just a little over 20,000, almost 21,000. It popped out okay. Roger, that's it. I got it.
When the parachute recovery is commanded, the 5-foot drag chute flares out first, bringing the initial sharp deceleration of the Firebee. After a given interval, the drag chute pulls the main parachute container to the rear, and the main 70-foot chute is deployed. The drag chute then detaches from the main canopy to float down to the ground separately, carrying with it the main parachute container. The target itself is lowered at a speed of approximately 18 to 20 feet per second. When the drone touches the ground, a swivel serving as a link between the parachute suspension lines and the nylon Weber riser attached to the target plane is automatically disconnected. This separates the chute from the Firebee instantly, thus preventing ground drag from strong winds and possible subsequent damage. While the target is descending, the chase plane pilot estimates the point of landing, and the recovery crew and equipment are dispatched. As personnel of the Air Force recovery crew prepare to load the target on the recovery trailer and return it to the hangar for a detailed post-flight inspection, it can be seen that the damage in the landing was confined almost entirely to the skin of the engine nacelle. While the Fairchild J-44 engine is specified in the tentative standard configuration, tests have also been conducted with the Firebee using the J-69 Marbury II engine. This recovery trailer is one of the standard pieces of ground handling equipment. In addition to belly launch from the bomb bay, the Firebee can be launched from a wing installation on the B-26. Similar wing launch installations can be made on B-17 and B-29 type aircraft. Reminiscent of the wartime practice of recording missions after each combat engagement are these parachute and target insignia which indicate successful recovery of the target. This particular Firebee has now completed 7 successful recoveries after test flights. Here we see the B-26 as it prepares to take off with a captive Firebee attached to the outboard wing bomb shackle for wing launch tests. The Firebee has also been designed for ground launching. Acceleration tests prior to the first actual ground launching were conducted using the 4,000-foot rail launcher at Holloman Air Development Center. The Firebee can be launched from catapults or with JATOs. The initial ground launching test was made from the Air Force Type A-1 rail launcher and was made without the benefit of any prior dummy firing. The steep angle of flight and oscillation in the first firing were attributed to improper detachment of the JATO bottle, which put the Firebee into a nose-high attitude. The initial ground launching provided the first test of the parachute recovery system at low altitudes. In this particular flight, the recovery was commanded at an altitude of 360 feet above the surrounding terrain. Here is how the same ground launching appeared from a ground observer station. The Firebee has reached the point of development where it now offers all the military services an economical means of training air-to-air gunners, anti-aircraft crews, and for the testing of advanced missile systems. It can be produced at a cost of less than 10% of man-carrying aircraft of comparable performance, which have been converted to drone operation. And the parachute recovery system permits repeated use of the Firebee target. In addition to the model tested by the Air Force and shown in these pictures, Firebees have been ordered by the Army and Navy.